All right, so y'all, this is a problem out of 6.1, and we're trying to find the area between the graphs of y equals 10 minus x squared and y equals negative 3x minus 30 over this interval. Okay, so first thing, I know we're going to find it over that interval. We want to see, are there any points where the two graphs intersect over that particular interval? So in order for me to do that, what I need to do is I need to set the two equations equal to each other to find those points of intersection. Okay, so I'm going to go ahead and move the 10 and the x squared over. And we're minusing 10 here. Okay, so now we have x squared minus 3x, what's that, minus 40. Okay, so we can go ahead and factor this guy. So what, a negative 8 and a positive 5? So we're going to get x equals 8 and x equals negative 5. Okay, so if you notice, the interval that we're looking at here, y'all, is between negative 8 and negative 2. And you know what? This one right here, negative 5, is going to be in that interval, right? Okay, so the question now is, which is the top function, which is the bottom function, okay? So the way we can do this, y'all, is I'm just going to do this on the next slide. So let me see, what are the two functions I have again? 10 minus x squared. So y equals 10 minus x squared, and the other one is a negative 3x and a minus 30. And the interval we're looking at is between negative 8 and negative 2. So the way we can figure out which is the top function and which is the bottom function is, let's evaluate it at these endpoints, okay? So I'm going to call this y1 and y2 just so that I know, which are that I have two different functions here, right? So y1 at negative 8 is going to be a 10 minus negative 8 squared. 10 minus 64, that's a negative 54. And then y2 at negative 8 is going to be, let's see, negative 3 times negative 8 minus 30. So that is 24 minus 30. That's a negative 6. Okay, so at this endpoint, y2 is my top function. So y2 is my top function, and y1 is my bottom function, okay? Now, let's do the same thing at the endpoint at negative 2. So let's find y1 at negative 2, okay? So let's see, we're going to have 10 minus negative 2 squared. That's 10 minus 4, that's a 6. y2 at negative 2 is going to be negative 3 times negative 2 minus 30. So that's 6 minus 30, that's a negative 24. Okay, so in this case, at this endpoint, my y1 is my top function, and my y2 is my bottom function, right? Okay, so since we're always going to take the top function minus the bottom one, what we're going to do is from negative 8, and then the point where they intersected was at negative 5. So from negative 8 to negative 5, from that interval, we're going to say it's going to be y2 is the top function, y1 is the bottom function, right? And then from negative 8 to negative 2, so over the next, from negative 5, to negative 2, then we're going to have the y1 being the top function and this one, the y2, being the bottom function. So let me explain what I'm doing here. Okay, when we're finding the area of a curve, it's always the top function minus the bottom function, right? Over whatever interval we're doing. Okay, so we're doing this over two intervals. The first part is going to be from negative 8 to negative 5. So from negative 8 to negative 5, our top function happened to be the y2. This was the top function. So it's going to be negative 3x minus 30 minus the bottom function, which was 10 minus x squared, okay, dx. And then we're going to add, we're going to go from the other interval, which is going to be from -5 to -2, from -5 to -2. And now my top function is y1, which is the 10 minus x squared, minus the other one is the bottom function. Okay. All right. So that's what you're going to do. You're going to simplify each of those two expressions, right? You're going to find their antiderivatives, and then you're going to evaluate them. Y'all, I just want you to notice something. We did this in class the other day. If you notice, the only difference between this expression here and this expression right here is that the order is switched, right? So when you find the antiderivative of this one, this is going to look very similar. It's just going to have, you know, that extra additional factor of a negative because the order is reversed, okay? But this is what you're looking at integrating, okay? So again, this is number 3, y'all, out of 6.1. Okay, if y'all got any questions, let me know.